Hi guys, and welcome back to Wade's Workshop. What are we going to be doing today? Well, all in relation to the Z-axis power feed. Now, this power feed project's gone on for quite some time, so I'm going to skip through a lot of the details, just quick, rough and ready, show you how I've gone about it, the odd dimensions, what have you, and how I've worked out what goes where. That's as much detail as I'm going to put into it. Okay, I'm using all the same hardware as used on the X-axis. Did I say X-axis earlier? Probably did. And Z-axis is what we're doing. There's going to be some milling, drilling, basically making slots, machining a plate, turning. There's going to be a bit of turning. We're making standoffs, that sort of thing. We're going to do a bit of boring on a pulley. Basically we have the end result of the mechanical parts of it in place by the end of this video. So yeah, fairly straightforward, this one, in comparison to the X-axis, which was quite involved. But yeah, far easier way of doing it I found this time. It's up out the way, up out the swarf. It doesn't need to be enclosed in a box. I'm not trying to build the switch work into the same area, you know, that can be done separately. But you'll see it as we go along. So enjoy, guys. So the first thing I've done is bored out the gear wheel or tusk belt wheel to go onto the hand wheel. I measured up the hand wheel and I bored it out with a boring head. I could have done this in the lathe, but it's difficult to hold. I could have, if I'd have held it on the outside of these rings, which aren't very firmly located, they don't run concentric to the gear. So difficult, I'd have had to clock it up across the top of the gear teeth or across the bore, and they're not that firmly fixed. I could have taken them off and gripped on the top of the teeth, but I didn't want to damage them. So the simplest thing, clamp it down flat on its base, and I bored it out with a boring head. Okay, so that's the pulley fitted to the hand wheel. It's got a grub screw down in the hole, which fits into the original slot, and another grub screw on top, which tightens it all in place. So I've just squared this block of aluminium up. I've spotted 4 holes with a 6mm spotted drill. And I'm just drilling them out 6mm with an idea to slotting these holes and putting a pair of slots in. So I'm just drilling the extremities using the DRO. And then I'll come up with a 6mm slot cutter, or a 6mm milling cutter I should say. And I'll slot between the 2 holes to make 2 slots, 6mm wide, 10mm long. There we are. So that's the drilling done. So I'll put a cutter up now and slot them out. Doing it in 2 hits. That's 5mm deep. Run that cutter a bit faster. Good, we're reading a 66, which is there, down to full depth. That'll do me. It's out the other side. Keeping the WD flow in here. Am I running at 1500 RPM? The 6mm cutter. I'm just hand feeding this. Back to my 56. There. Just go back the other way. Clean it up, back to 66. There. I can withdraw the cutter, switch off, and that's my second slot done. I'll try and explain this better in a minute. What I'm going to do, I need to work out where in relation to the 2 bolt holes where this bolt's on, the motor's going to go, and the motor is going to sit on its 4 bolts. Let me get the motor. It's 4 bolt holes on some standoffs, some turned spacers, with a tapped hole in the end that are screwed into this plate in a certain position, and it's got to revolve a little bit to allow clearance for the bolts and the rods of the belt. we'll come to that momentarily. Basically, first thing I need to do is know where the centre of the shaft of the motor is going to sit. Now, I want to offset it to push the motor further back away from the handwheel and away from the front of the mill. So that's going to do it by me offsetting it, not having it in the middle. I'll offset it one way. So my thinking is I want to offset it right back to the sort of centre of this radius, so that as I slide this back, it's going to tension the belt. I can slide it back on the slots to tension the belt, and it gives me plenty of scope. I'm going to come back a few mil from the very tight spot, but I'm going to measure the pulley when I pull the belt, how far down from the bolt hole at the back it is to the centre line of the pulley when the pulley is in spot. I'll show you that next. It's probably the easiest. So the two slotted holes are going to sit in these two bolt holes with longer Allen bolts with washers on the top, and they will clamp the plate onto here and clamp this location of the housing in and what have you. So that's how the plate is going to fasten onto here. Now, pulley's in place on the top, pulley in place on the bottom. If I pull that down and offset it to the centre line of the rear pulley, I'm basically going to get in there with a rule. Hold on a minute. Figure had changed. I'm not on the pulley, I was on the plain bit. Right, okay. Look at the centre line with a vertical drop. Line up the centre in this direction vertically. And as I look through the hole in the gear here, or pulley we'll call it, I'm getting 50 mil. So at the offset centre line of the rear hole, I need to be down to the centre of the pulley 50 mil. So we'll go back to the block now. So I've just scribed the line down here, doesn't show up very well, 50 millimeters. I've scribed the line on the end of the slot, which allows for maximum tensioning because the plate will move further away, and as it does, the centre between the top pulley and bottom pulley get further apart, tension in the belt. I think I'm going to give myself a little bit of leeway, and I'll come back from there 3 mil, so that in case that is actually 49, that measurement, or 48.5 or something, I've got a bit to play with. So I've got a spot here. Sharpie, not going to Sharpie it out, I've got a pencil. It's here. And that is the centre of the hole. So what I'm going to do, I'm going to cheat a little. My parallel's just under there. What I want to do is I'm going to drill a hole through there. I might have to do a bit of adjustment, but I'm going to drill a hole through there to take the shaft of the motor, even though the motor shaft won't be anywhere near that, but just to give me a location. And then I'm going to rotate the motor and mark the 4 holes onto the plate somewhere where I can get the maximum amount of rotation without coming off the edge of the plate. Bearing in mind this piece of plate is a leftover from when I did the X-axis power feed. So I've just put a 6 mil hole through, 10 mil collet, in the collet nut. Here we are, that's a 10 mil drill in. Just tighten up that collet. Okay. Have we got the scope? No, we've got to bring the head down. Aha. When I got the power feed, I won't be reaching over there. I'll just be undoing the lock and jobs are good. Right, what speed we doing? Too fast more than likely. And there we go. 10 mil drill. Okay, let me just set some zeros on the DRO there, come out of the way, give it a clean off. Let's just make sure the motor shaft fits in that 10 mil drilled hole. They normally drill just over, so it should fit. Let's just try. It does all bar a burr in the bottom, I think. Oh no, it does fit. I'm going to have to take that clamp off, but that's fine. So yeah, that's the location of where the motor spindle is going to go. So yeah, I can remove this clamp. I've got the other one in position. They're only loosely tightened up. I didn't want to bow the plate here. Tighten up for drilling. Let's have a look. Where's my Noga? over there behind the camera. Just deburr that hole. Okay, get stepper motor back. I think we'll put the wiring for the stepper motor. Oh, that's a bugger, I'm on the table. Not to worry, we'll unclamp it, move it back a bit, and then I'm going to mark some holes. So we'll do that while we wait. There somewhere. I was hoping the motor shaft would drop down the slot on the table. I have now, and I'm on the register on the front of the motor, so not to worry. So what I want to do is turn the motor as much as I can this orientation, which is about there, and that will allow, if I put it vertically like this, the belt coming off the pulley is likely to hit the bolt hole. So I'm just going to give myself a little bit of leeway, something like that. Okay, so what I'll do is I'm going to, how can I do this to make it simple? I know the sizes of the 4 holes, the distance apart. I know the center hole. If I angle the plate to make the motor square, it might be a cunning plan. Let's have a look. Whoops. Let me angle the plate around to make the motor square to the bed, while still being able to drill and tap some holes. The pillars that I make can be a bit bigger, but there's going to need to be some clearance holes in here, or even tapped holes. I'm going to go for that angle. I'll just cock the plate over. Let me get my parallel out from underneath where the hole's going to go. Okay. Let's put the motor square. So I can clamp on that side. Now take the motor out the way. Know how I make things up as I'm going along. I'm doing it again. Right, okay. So you can get the gist of what I've done. Instead of having to work out a weird angled set of holes, I've got the centre point. That will clamp there nicely, I think. That's clamped there, that's clamped there. Should be out the way of my holes. Okay, so I can pick up that centre hole again now, which is quite easy to do. And then I know where the square of holes is. You know, the distance out from centre in X and Y for the 4 holes. So I can now drill them, and that will automatically twist my motor around. But what I've done is twisted the bracket round for in the same way. You get the picture. So I've just picked up the centre. It's not dreadfully fussy. I'm using the drill bit. Okay, pretty easy to do. You can eyeball a drill bit, turning it through 90 degrees in both directions. Won't manage to get that out of there. Right, I'm going to put my chuck back up now, which is that collet there. Yes, it is. I always check the collet first. That's the one. This chuck takes up to a 1/4 inch drill. This chuck, my little Rome chuck. Oh, I'm going to have to wind the head up a touch. Okay. There we go. I tighten my chuck up. I think I'll get a 6mm spot in drill again. Oh well, there's a 5. In fact, I'm going to use 5mm bolts here, so 5 was actually better. So I need to know now the coordinates in X and Y of where the 4 holes are on the motor. So very kind of the stepper motor supplier. 47.14 plus or minus 0.02. So I'm going, no, 0.2. Right, so I'm going to set them at 47.1 mil. Half of 47.1 is 23.55. So I'll offset 23.55. While I've got that in my head, I'm just going to write down the figure. So from my 0, 23.55 there. Offset this way, 23.55, which is there. Spot the hole. I just as well do this axis while I'm at it. 23.55 this way. There. Now, positive 23.55 is going to be very close to the edge, but that was the plan. And 23.55 this way. There we are. Okay, so I spotted the holes. The holes in the motor are 5.2 drilled. So I'm going to use M5 for my standoffs. I'm going to use M5 both ends to screw the motor onto the standoff and the standoffs onto the plate. So in fact, looking at the size I've got here, let me just get an M4 countersinking bit. I have got one. There it is. Oops. So if I was countersunk in the back, that's not going to come off the edge, and nor is that one. So actually in the plate here, I'm going to do M4 clearance holes. So I got a 4.3 drill up. Running a little slow. It's better. I may get a little bit close to the parallel on this one. 23.55. There. Yeah, I'm not going to get right through, not to worry. I'll just mark it. I'll drill that one when I take it off. Okay, 23.55. Too much. There. And oh, too much again. Okay, so that's the 4 locations where the standoffs, which I've yet to make, are going to sit. So get my drill over a gap in the table. Just do that one blind hole. Okay, so I need to deburr those on the front. Oops, drop the drill in the slot. The deburring bit. use a Noga on the 10mm and on the elongated slots. Okay, so I put it down that way, and I need to counterbore the holes for M4 Allen bolts. So I think that will fit the chuck. I'm dropping everything today. It will. So set a 0 on the Quill Diaro. I'll just measure up an M4 Allen bolt and see how deep I've got to go. I've just had a measure, and the heads on the bolts I've got, the particular ones, they can vary slightly, with 4mm, so 4.5 deep. Just plunging in. 3, 4.5, and up you come, grow the beard, and I'm over the edge on this one, so I think I might just put a little clamp on it, because I'm going to get an intermittent cut with this, and it could jump around, as they say. So I'll just locate that there, get my clamp, let's have a little clamp in here. Oh, can I get that low? Yes. Yeah, holding in your hand when you got something like that with it, I mean, it should clamp it down anyway, but holding it in your hand when you've got something all over the edge there like that is a bit dodge. So let's just check my 0's still good. Yes. So I'll just do this 4th one. You probably can't see from where you are now. I've probably moved everything. But yeah, we'd like you to jump around. We don't want to hurt our fingers, do we? I'll show you the edge there. As you can see, it was breaking out of that edge, and it probably would have been fine, but why take chances? So just to show you the general plan, I've got some longer Allen bolts. I'm going to pop these 2 bottom bolts out of here. That's that one. They weren't very tight. I've never had this off here. I've had the hand wheel off earlier, obviously, to put the pulley on. Okay, so that's those 2. I think the bolts I've got may be a little long, but you'll get the general idea. So the standoffs are going to bolt on with Allen bolts from the back, so basically round pillars. Yeah, these are going to be way too long, aren't they? Oh, I don't know. Yeah, I think we're all right, actually. I guessed it. I was when I planned it, I thought, have I got any longer M5s? I think these are about 35mm long. So there's a bit of jiggle room because it's a 6mm slot and an M5 bolt. They got washers on them. So I'll just nip those 2. I will if I can ever do it upright. Okay, so that's that in place. If I just hook the belt over on the pulley now and get the other pulley, you can see that I'm actually a little bit too far up. It's going to be somewhere around there. So if I loosen those off, and I'm going to have to undercut the back of this along here. And now I'm not on the end of the slot, and that's too low. So I'm going to be within the range that I need, and the motor's going to sit back there. Let me just pull those out of the way. On some spacers that are going to sit using these holes. Probably put the belt at the back there, and the motor will sit, as you can imagine, on an angle like that. And that gives the opportunity for the bolt pillars to miss the belt, I hope. I may have to put some flats on the pillars just to gain that little bit. let's have a play with it. Yeah, if I put it square, the back hole here gets very close to the belt, hence why I've twisted it. I've offered it up before. So yeah, this one, plenty of room here. The back one here is the problematic one. But I think we're going to be okay. So far so good. Make some standoffs now, so I'll have to measure a dimension between this plate and to line the two pulleys up. So between this plate and that pulley, see where this pulley is, how far this pulley's got to be out, we'll go from there. So on the mill, the distance from the outer edge of the plate to the working edge of the pulley, this edge, let me think, that's going to be on that way round. The distance to the closest edge to the plate, so the plate's going to sit here, was 12 mil. So if I put that pulley on basically flush to the end, that'll allow me a bit more. With that being 22, so 34 millimeters is the length of my standoffs. 34. So I need to write that down and get to the lathe. So I've been searching everywhere for some 10 mil silver steel, enough to make these 4 standoffs. I couldn't find any anywhere. I thought I had a stock of it. And then I remembered I bought a length of bar 3/8. So yeah, close enough for the purposes. So I'm going to chop a piece of this off and we're going to make them out of 3/8. So I'll put a piece of bar up in the lathe. I'll just face the end and chamfer this one end. A touch on, little cut. That's it faced. Change to a chamfer tool. I got a great big chip out of this tip from a previous encounter. Just break the edge of that. Okay, so let's bring him out. 40 millimeters, ballpark 40 mil. Okay, change to a parting tool. I'll just line the edge of the parting tool up with the edge of the work. There, give myself a 0. I think I'll come back 34.5 to allow me to face the other side afterwards. Pass it off. Back to the turning tool. And much the same again. Face this end. Chamfer. Mil stuck out. Parting tool. Exactly the same procedure until I got 4. I'm going to be repeating this. Oop, out a bit more. There, set a 0 on the DRO, 34.5, lock, lost my brush, there we are. the first one to length, 34.54. So what I'll do is when I grab the next ones, I'll just have a quick measure first. .5, so that one just needs cleaning up. And this one, again, just needs cleaning up. Okay, so I've got a little centre drill up. And the idea being now, basically centre drill both ends of all four. So we'll do this M4 first. I'm going to go 15mm deep, which is more than enough. So 1, 2, 3, 4, 5, 7, 8, 9, 10. Bring it back out. Touch in. 8, 11, 12, 13, 14, 15. It's going to be more than deep enough. That's the tapping drill for M4 in one end of them all. So now onto the other end. Tapping drill for M5. I'm going to go 15 turns deep again. So yeah, off to go. That's the drill parallels. 1, 2, 3, 4. I was going to tap them on the lathe. I just got them started on the lathe. A couple of turns. I thought I'd finish them off by hand. Yeah, it's just I do like hand tapping. I think it's quite therapeutic. Unless you've got 1,000 holes to tap, of course, and then it gets tedious. When you're tapping M4 instead of M5, which I was just now, I do take it a bit more gently. I've got a small tap wrench. I'm breaking the chips with every half turn, and I am tapping it down into, not right to the bottom of the hole, I mean in probably 12, 13mm deep, something like that. Okay, well that's it in place. The risers are bolted through with the M4 cap heads from the back of the plate. Plate's in position, everything's lined up. Looks really good. Now, I've got a little bit of slack in here, too much slack, and I've got to admit, when I moved that hole over 3mm, I shouldn't have. So what I'm going to have to do is just elongate these two slots, not a huge problem. Elongate them maybe another 3-4mm. That'll bring this bolt, right, close to the edge or what have you, just to be able to push it back a little bit more. But yeah, I'm sure that's going to be absolutely fine. I'll bring you around the other angle. So you can see now the purpose of twisting the motor back on an angle to avoid the belt hitting this pillar, and the one at the back is actually in clearance as well. So yeah, it's absolutely fine. It's not hitting anything. So that's it sort of brushes the pillar at the back here. When I give it that little bit more angle that way or push it that way a little bit more, we may miss it. I'll have a look at that. Worst case scenario is I'll mill a flat on the little pillar. You can just see it now. Yeah, it's down in there. It's just clearing that pillar, but as you can imagine, if I'd had the motor straight, that mounting point would have been right in the middle of where the belt's going to go. So moving forward from here, I do need these two bolts. I've got one in each diagonal. Were the ones that came out of the head casting originally, so they were the right length. I've only got some 25mm long ones. I need to, well, I'll cut them shorter and put 4 in the same. So I need to do that. I'll think about guarding the belt to keep the fingers out, but I don't think there's going to be an issue, and it's certainly not a swarf issue up here. I'll elongate these slots so that I get the extra travel to be able to tension the belt correctly. Yeah, that's an oops on my part. Oh well, these things happen. The other thing, wiring. Yeah, I mean, basically just 4 wires. The motor and the hand wheel don't move, so, you know, in relation to the mill. So that'll just be a piece of trunking coming up and connected into these 4 wires here. Don't need to have plugs and sockets like I did on the other one, which, you know, with wires bending, moving all the time, if I ever get any problems, I'm going to rewire the whole system down below. It's on plugs and sockets, so don't think I need to do those up here. What else? Yeah, I was thinking, well, control for it. I was thinking at one stage a switch or a box up here, you know, one of these sort of tin boxes, you know, the cast alloy jobs with a couple of switches, an up and down and an on and off. I'm not sure. The issue I've got is I don't want to inadvertently switch on the motor when the locks are on the other side of the head. So I think I might put an interlock on one of the locks. I only ever use one. Let me show you the lock on the other side. Yeah, you can just about make out the lock here on the other side. Let's get that out of the way, that one. There's a lock here, and down, that locks the head, and up unlocks it. I may have an interlock switch, something that picks up off this, so that it'll only work when the lock is off. I never use the lock at the top. It's just too fiddly to get to. I just leave that loose. But I may have something here with a little micro switch again, you know, in a little box maybe, or just a switch, I don't know, so that if I go to use the power feed with the lock on, it won't work. It just doesn't do anything, and that'll remind me, oh yeah, undo the lock gate. Yeah, I think that's going to be useful. Again, limit switches on here. I think I need something on the top. The top of the moving part can come so far up, about this far, about this point here, before, well, I touched the roof eventually. I mean, I could put something on the roof of the shed so that when this comes within a certain distance, it cuts out and kills the feed. That's a possibility, but I think build it into the mill is probably the best, because the roof might move and what have you, you know, up and down, swelling and all. Yeah, so I think it's best to have it built into the mill. And again, something on the bottom, maybe a little tag on here and a switch down here, you know, linked into all 3, so that if any one of these 3 switches are made, the one on the lock, the one for the height, or the one for the depth, as it were, I may make the depth one adjustable with a final stop, so you can't go lower than a certain point, and make it adjustable so you can bore using the power feed to a depth. That's a thought going forward. So yeah, lots of bits and pieces to think about. Much the same as we did on the X-axis, really. So I'll probably knock all those bits and pieces up off camera at a later date, and then keep you informed as we go along. Oh, one other thing. This bracket, as it stands, well, it's ugly looking thing, isn't it? So obviously I may, you know, put some nice, I don't know, bring some angles up or something like that. You know, knock that top corner off. I don't know. We'll see. We'll see how it goes. Well, I think that's about it for this one. Yeah, I don't want to show too much, you know, on this, because we went into quite a lot of detail on the X-axis. So the Z, it's fairly simple, as you've seen at the end. There's not a great deal to it. It's just figuring out sizes and shapes and what's going to fit where. Again, it was a make it up as you go along job. Oh, I was asked a few weeks ago, and I've probably shown them a few times. Well, not shown them directly. People ask about my watches. I'm a bit of a watch fiend. I do various repairs on watches. Well, you've seen my video on clocks and what have you, that where I was working on a clock. I literally haven't got anywhere near doing that clock yet. I haven't taken it apart, even the movement. It's just time and all this COVID stuff and all the rest of it. Just literally haven't had the time. Time, no pun intended. Anyway, I'll show you one of the watches I was wearing today. It's probably come up in the video. This is what I call a clunker. What's a clunker? Wear it every day, abuse it, use it. You can't hurt the thing. Waterproof, shockproof, does whatever, made of kryptonite. Well, they're not. You know, hit it with a hammer and you're going to smash it up. But, you know, while it's on your arm, you're not going to hit that with a hammer. And if you do, well, you shouldn't be wearing a watch if it's that stupid, because you can't tell the time. Anyway, I'll show you the watch. It's a G-Shock. Here's the boy there. It's a G-Shock. It's carbon core guard on it. Why yellow? Well, I like yellow. I wear it for work. It's a grubber. It's fairly new to me. I've had it a month or so. Yeah. They're not expensive. You know, I don't know what they are. UK price, if you go into a jeweller's shop, they're going to be over £100. They're going to be 120 quid, something like that. You buy them online, it's going to be £80, £89, something like that. US, you know, $100, $110 maybe, I don't know. But good Casio, you know, G-Shock, does everything, got different time zones. I don't use any of that stuff. It's got a chronograph on it, got alarms on it. Yeah, cheap and cheerful, and bloody strong, robust watch. Ideal. I don't advise wearing a wristwatch on when you're operating machinery, particularly little tiny machines like I've got in my workshop, fine. But you know, when you're on big lathes, big mills, you got your arms in the way, swarf can come out. You don't. I wouldn't recommend any jewellery, certainly not rings. But that's pretty much the story with that one. Yeah, people have asked. You know, I've got various watches. I'm not going to mention how many, but yeah, I could do a few series on the watches I've got and the reasons I've got them and what have you. But as I say, this one, it's a clunker. It's for wearing to work. Yeah, it's a good one. I've got an old watch. It was a Pulsar. Which I stripped down. Oh, I think I did show myself stripping it down quite some time ago. Put it all back together, and it was that nice. It had a lot of, I'd had it a long time, 30 plus years. Stripped it, put a new movement in it, cleaned it up, polished the case, polished the glass, new battery, put it back together, sorted the bracelet out, polished that. Everything looked tickety-boo, and it was too good to wear to work then, because I'd had it so long and I didn't want to ruin it again. So I haven't been wearing a watch to work. Nobody needs a watch nowadays. You just use your mobile phone. I don't carry my mobile in work. It stays in my bag. Hence, yeah, bought myself a clunker. Anyway, guys, I've rabbited on for long enough, haven't I? Thanks for watching, guys. Thanks for subscribing, and we'll see you all very soon. Cheers now.